Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so question 6 on that 2020 paper was your calculus question. So differentiate the function f of x equals to 4x cubed minus 3x squared plus x minus 7, where x is an element of r with respect to x. Okay, so differentiate the function. So calculus, okay? And I'll explain briefly what calculus is, and then we will do it. Did I just go past him? Yeah, there. Okay, so there's a calculus page in your log tables, page 25. This is the section that's super important, but it's mainly just the first line, okay? So I'm going to come back to that in a minute, but after I briefly explain, because the first calculus question I've done with you, briefly explain what calculus is. Okay, so as you know, in coordinate geometry, we draw lines on a regular basis. These could be sails of face masks. Well, no, let's go. This is 2020, months in 2020. And this is sales of face masks or something like that, okay? Seeing as we're in COVID times, okay? So as time went on in 2020, the sales of face masks grew. If you need to find out the rate of sales, and in English that means how fast is sales growing, you would get the slope of that line. Okay, because the slope or the slant of that line is the relationship between time and sales for this particular graph. Okay, how would I get slope? Well, I would take 2 points on it, and I would go y2 minus y1 over x2 minus x1, okay, the slope formula. Or you would do rise over run, which is the same thing, y being rise and run being x-axis. So whichever way you get slope, but either way you would get slope, okay? And you all know how to do that. And then of course you can get the equation of that line using slope and a point on the line, and all's happy out. Okay, and super important that you know the rate of change of that line. Why is that super important? Because, well, if you're a supplier of face masks, you want to know in the future how many face masks are you going to need, because you want to maximize your sales. You want to make the most money you can, so you want to have your stock ready. Okay, now here lies the problem in life. Are most things in life a straight line? Never. Okay, so those rate of change, if we stay with face masks, wasn't like that. None of us wore them for ages, few wore them, and then all of a sudden it shot up. Okay, when they became compulsory. That's more like the rate of sales of face masks. And if we continue on in time, at some stage it will peter off, and then hopefully, all being good, oh, my pen won't work for me, all being good, we will stop wearing face masks, okay? And that's the normal pattern of things. But let me give you another example of a curve, and let's do a phone. Let's do the Apple iPhone, whatever the latest one is. What does the curve of sales look like for the iPhone? So let's do sales of iPhone. Let's do time on the bottom axis, okay? So as you know, sales of iPhone tend to have a shoot up at the start, and then they kind of peter off a bit, and then they shoot up again, and then they start to dwindle down. Okay, and this would roughly be the curve of the sales of any technology piece. Okay, so these are I suppose, the people who are passionate about the iPhone. It could have been the same when the PlayStation 5 came out. There would be a certain amount of people that would have pre-ordered that, would have saved up for it, and will get it the second it comes out, okay? Why is it only a small amount? Well, why does it, I suppose, peter off here? Well, it's really expensive at the start. Any piece of new technology is really expensive at the start. So people can't afford it here. These are the eager beavers who love technology and will do everything they can to have it, okay? Then these are the normal people who would like it but can't afford it. The price starts to come down, and then, of course, sales grow. Then what happens here? Why is there a turn? Well, some new technology will come out and replace it, and sales will drop off. Now, the likes of Apple needs to know this curve, because they need to have the exact amount of, or try to match how many phones they make with demand. Now, how do you calculate the rate of change of this curve? Okay, remember when we did the last one, it was a straight line and we used slope. Okay, how do you get the slope of a curvy line? Okay, because that is most things in life. So if you think about flooding in rivers, because it's January, okay, you look at the amount of flooding, and then, of course, the council need to know the rate of change of water in rivers, so they need to know when to put out sandbags. The government needs to know the rate of change of employment or unemployment in the country, because they need to know how much to budget for social welfare. They need to know the rate of change of people out of work because of COVID, because they need to know how much money to put aside for the PUP payment. Okay, so it doesn't matter what branch of life you're in, you need to know rate of change. The chapter that covers the rate of change of a curve is calculus. Okay, so instead of getting a slope value for this one, pretend I'd put that into the slope formula and I got a slope of 3 for that entire curve. What you'll end up doing is, when you get the slope of a curve, you end up getting a formula for the slope. Okay, often called dy dx. Okay, but it is slope, it's the same thing, and you get a formula for it. Why a formula and not a number? Well, it's because as you travel along that curve, the slope value changes. Can you see that? So quite a steep slope, a very small slope, steep slope again. The top of the curve, the slope is actually 0. A negative slope, quite a steep one, and a less steep curve here, so a less minus number. So that's why you get a formula for slope instead of a slope value. Okay, can I ever get a slope value then? Well, yes, we'll say if you decided that this time was important, right here in the peak, you wanted to know the rate of change, the highest rate of change, whatever is the x value there, you sub it into your slope formula and you get the slope at that point. Whatever point that is, you sub in the point and you get the slope at that point. Okay, so that's what I'm going to be doing with you with your calculus questions, is that type of a setup. Okay, so let's read the question. Differentiate, so that means is find a formula for the rate of change. So differentiate the function f of x equal to 4x cubed minus 3x squared plus x minus 7. Okay, so when you differentiate something, let me just do some of the terminology first, okay? You can say I'm differentiating this equation y with respect to the letter x. That's what dy dx means, okay? And you differentiate it, and I'll do that for you in a minute, okay? So you'll see that terminology around the place, okay? Dy dx. The other one you see is what's written here. F of x is equal to 4x cubed minus 3x squared plus x minus 7. To show that this is the differentiated bit, you'll see this little dash up the top, f dash x. Okay, so that means this is the original function, this is the differentiated version. Okay, and like I always said, for functions, y is f of x, so you can see it written as f of x or written as y. So you can say dy dx or you can say f dash x, it doesn't matter. Okay, now how do we differentiate? Well, this is this rule that's here in the log tables. Okay. Okay. So it's mainly that first one that's on your course. Okay, higher level, use the whole table. So what does it mean? Or how do you read it? This is the original function, f of x. This is the differentiated answer, f dash x. So what it says is, if you're differentiating x to the power of n, you take down the power in front and you reduce the power by 1. So you see n minus 1. You subtract 1 of that power. So for example, if I had x to the power of 5, if I differentiate it, I take down the power in front and I subtract 1 off the power. So 5 minus 1 is 4. That's it. Okay, x to the power of 6 becomes, take down the power, reduce the power by 1. Okay, if I had to do 2x cubed, for example, what do we do when there's a number in front of it? Okay, well, take down the power. So it becomes 3 times 2x, reduce the power by 1. So 3 minus 1 is 2. So that becomes 3 2s or 6x squared. Okay, let me do 1 or 2 more troublesome ones, okay, or harder ones. What happens when it's just x? How do I differentiate that? Well, remember x is to the power of 1, okay? We just normally don't write it in. So take it down in front if you want, and then subtract 1 from the power. Okay, so I'm just doing this the long way now first. So that becomes 1x. Oh, subtract 1 off the power. I did the answer in my head. Subtract 1 off the answer, off the power. 1 minus 1 is 0. Anything to the power of 0 is not 0. Okay, as you think, it's 1. Anything to the power of 0 is 1. So this becomes 1 times 1, which is 1. So if you differentiate x, you get 1. Okay. So what would I get if I differentiated 3x? Well, take down the 1. So take down that 1. So it becomes 3 times 1 is 3. X to the power of 0, or it'll just be 3. Because this whole thing is 1. Okay. So it's like you're throwing away an x every time. Okay. X to the power of 4 becomes x to the power of 3. X to the power of 3 becomes x to the power of 2. A single x disappears, it becomes 1. Okay, now, last bit I'm going to show you before I differentiate above is what happens if you differentiate a number, so the number 5. Okay, so that number 5, f of x is equal to 5. Let me write it down as f of x equals 5, okay? So f of x equals 5. If I'm going to plot that number, remember I said f of x is y, okay? 1, 2, 3, 4, 5. Imagine this was straight. I'm plotting the line y is equal to 5. That's actually a flat line at 5. So what is the rate of change of that line then? How much does it change as I move across in time? Well, you can see it doesn't change by anything. So the rate of change of a constant, because that's a constant, it's a constant 5, is 0. Okay, the slope of that line, so therefore dy dx or f dash of x, the slope of that line, the rate of change of it is 0. Rate of change is slope. Okay, So therefore, if I ask you to differentiate 5, your answer is 0. Okay, so that is roughly what you'll be using when you differentiate. So let's come back up to our question and let's differentiate this. So take down the power, reduce the power by 1. If you learn that off by heart and you say it in your head, it'll keep you straight. So take down the power. So you can leave the 4 there. It doesn't matter which goes on the outside or the inside. So leave the 4 there, take down the power, reduce that power by 1. Keep the minus there, keep the 3 there, take down the power, reduce the power by 1. X goes to 1, minus 7 goes to 0. Okay, let's tidy up. 4 3s, 12x squared, minus 3 2s, 6x plus 1. So f dash of x is equal to 12x squared minus 6x plus 1. So that is the formula for slope that describes the entire curve. And sorry, that's not the curve that matches this one. But when you plot that curve, this is the formula that describes its rate of change or its slope. Okay, so part 2. Find the slope of the tangent to the graph at the point 1 minus 5. So what they're doing now is they're picking a point in time, just like I did on my example, the point 1, 5, and they're saying, what is the slope at that point? Well, you know that the slope formula is 12x squared minus 6x plus 1. So therefore, the slope at the point 1 minus 5, okay? So that means at the point, and there's the point that I want to do it at. It's just maths language. You don't have to be able to write it, but it's handy. Label him x, y. So you can see it's actually only the x value that gets subbed in because I only have x values in my equation. So it becomes 12 times 1 squared minus 6 times 1 plus 1. So if this is the point that you want to find the slope at, the actual value at that particular point, because you can see it changes, the slope changes at every single point across that curve. If you want to find the slope at that particular point, sub the x value of that point into your slope formula, which is your dy dx or your f dash of x, okay? And then put that into the calculator if you want, but 1 squared is 1, so that's 12 minus 6 plus 1. 12 minus 6 is 6, plus 1 is 7. So your slope is 7 at that particular point. Hence, find the equation of the tangent to the curve at this point. Well, the tangent, if I could draw a tangent on my messy diagram, a tangent is just a straight line, okay? I'll pick a different color to draw it. It's just a straight line that touches a curve at one point, okay? Remember that from circles. A tangent just touches the curve at that point, okay? So if it just touches the curve at that point, he ends up having the same slope as that point. So you can take your slope from above. The point in question is 1 minus 5. So he's your x1, y1. Okay, that's why they gave you the y coordinate. And then to get the slope of any line, you know that a slope, or sorry, to get the equation of any line, y minus y1 is equal to m times x minus x1. Tangent is just a line. So sub in y minus your y1 is minus 5 is equal to slope times x minus 1. Okay, so y minus minus 5 is y plus 5. It's equal to 7x minus 7. Merge the two numbers. Y is equal to 7x minus 7, and he'll become a minus 5. Y is equal to 7x minus 12. So that is the slope of that tangent to the curve at that point. Okay, so now you see why I spent that little bit of time explaining why calculus, what it is, how it relates to slope, and so on and so forth, because these are that is the foundations of the theory behind the questions you're going to be asked. Okay, part B then of that question, the function g of x is equal to 2x squared plus px plus q. So this is a functions question where p and q are integers and so on and so forth. Given that g of 2 is equal to 6 and g dash of 3, a little bit of calculus in it, is equal to 9, find the value of p and the value of q. And then it tries to help you by telling you it's the value of the derivative. Okay, derivative being differentiation. Okay. Well, let's deal with g of x2 first. So I have g of x being equal to 2x squared plus px plus q. Okay, now it's got two unknowns, p and q, and we have to find them. Two unknowns, the back of my head, simultaneous equations. Okay, always two unknowns. That's generally what's popping around in my head. Is this a set of simultaneous equations? Okay, so what's the first piece of information they gave us? They told us that g of 2 was equal to 6. G of 2 is equal to 6. Okay, so therefore let's find g of 2. So x is being replaced with 2 here. So you have to replace it with 2 all the way along. So x is being replaced with 2. So it's equal to 2. And just remember BOMDAS, so I have to do this bit first. So 2 squared is 4 plus 2p plus 2q. 2 4s are 8 plus 2p plus q. Okay, and sorry, I had another piece of information that was equal to 6. Okay, so I'm going to bring over the 8 or subtract 8 from both sides. So 2p plus q is equal to 6 minus 8. 2p plus q is equal to minus 2. So that looks like the first equation in my set of simultaneous equations. Okay. And then it got a little bit different after that. So g of 3 is equal to 9. So g dash of 3. So I need a formula for g dash so that I can sub in the 3, okay? I don't have a formula for g dash yet. So all they gave me was g of x. Okay, so let's find a formula for g dash of x. Okay, so again, take down the power, reduce the power by 1. Okay, remember the power here is 1. Take down the power and the x disappears. It'll be x to the power of 0. Plus q is a constant. Okay, these are just numbers. So if you differentiate a number, you get 0. Okay, so 2 2s are 4x plus x to the power of 0 is just 1. So it's just p. Okay, so that was tricky enough now trying to find g dash of x of that one. Okay, and then they told us that g dash 3 was equal to 9. So let's sub that in. X is being replaced by 3. So I have 4 times 3 plus p, and it's equal to 9. 12 plus p is equal to 9. Bring over the 12. P is equal to 9 minus 12. P is equal to minus 3. Okay, so that's my second piece of information. Now, as it turns out, it's not a set of simultaneous equations because this q went to 0. Okay, I know what my p is, so I can just sub them in to find q. So sub into 1. So I have 2 times p plus q is equal to minus 2. 2 by minus 3 is minus 6, plus q is equal to minus 2. Q is equal to minus 2. Bring over the minus 6 and it becomes plus 6. Q is equal to 4. So therefore, I'm going to write it in red. Your g of x is 2x squared. I'm filling in my values. I have a p here now. P is minus 3. Minus 3x plus q. Q is 4. So that is actually what your g of x is. Okay, find the value of p and the value of q.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.